What if the most brilliant engineers on Earth aren't human at all? For centuries, the ocean's depths have held their secrets close, dark, silent, and almost unreachable. But now, we're beginning to listen to its whisper. From creatures that thrive under crushing pressure to organisms that glow in eternal darkness, nature's deep-sea inventions are rewriting the rules of science. And today, those secrets are helping us solve humanity's biggest challenges in medicine, technology, and sustainable energy in ways we never imagined. Before we dive deeper into the ocean's secrets, make sure to like this video, subscribe to the channel, and turn on notifications so you never miss our next deep discovery. Imagine standing on the edge of the known world, the surface of the ocean. Beneath lies a realm so vast and unexplored, we know more about the surface of Mars than we do about our own seafloor. But hidden in that darkness are creatures that have been perfecting survival for billions of years. They've solved problems that still baffle our greatest scientists, from generating light without heat to surviving pressures that would crush a submarine like a soda can. This is where biomimicry begins, the art and science of learning from nature's designs. It's not just imitation, it's evolution's greatest hits, lessons written by 3.8 billion years of trial and error. When we look to the ocean, we're not just seeing strange creatures, we're seeing blueprints for the future. Down here, the rules of life are rewritten. The pressure is immense, over 1,000 times what we feel at sea level. For most living things, that would mean instant collapse. Yet somehow, deep-sea creatures thrive. Take the Hadal snailfish, for example. Living nearly 8,000 meters deep, its body is soft, flexible, and perfectly adapted to withstand intense pressure. Scientists studying its structure discovered proteins that prevent its cells from collapsing, inspiring new materials for deep-sea exploration vehicles and pressure-resistant equipment. Then there's the problem of light, or rather, the lack of it. In the blackest depths, the anglerfish wields a natural lantern, glowing with the help of bioluminescent bacteria. This eerie light isn't just for show, it's for survival. It lures prey, communicates, and even protects. Humans are now learning from that glow. Engineers are developing bioluminescent-inspired lighting systems that generate light without heat, far more efficient than traditional bulbs. Medical researchers are even using bioluminescent proteins to detect diseases in the human body, allowing us to see cancer cells before they spread. And what about creatures that live without light at all? Some deep-sea organisms have completely lost their eyes, evolving new ways to sense their environment through vibration, magnetic fields, or chemical changes. These adaptations are inspiring technologies for autonomous underwater drones, allowing them to navigate where cameras and sonar fail. The ocean doesn't just survive in the impossible, it thrives there, showing us how to design technology that can do the same. In the deep, movement is art. Every flick, pulse, and glide conserves precious energy. Take the jellyfish. It moves with near-perfect efficiency, propelling itself through water using a rhythmic contraction that wastes almost no energy. Scientists have studied this movement to design underwater drones and robots that move silently and efficiently, just like jellyfish. Then there's the squid, nature's underwater rocket. Using jet propulsion, it can burst forward at incredible speeds. This principle inspired jet-based propulsion systems in aquatic robotics and even early submarine design. But survival isn't just about movement, it's about defense. The cuttlefish can instantly change its skin color, texture, and even reflectivity to blend into its surroundings. Its skin contains thousands of pigment cells called chromatophores, working together like living pixels. This has inspired adaptive camouflage materials, stealth technology, and even dynamic fabrics for clothing that can change color on command. And let's not forget communication. In the silent, dark world of the deep, sound and light become languages. Some creatures use pulses of light to signal others, almost like Morse code. Others, like whales, communicate through low-frequency vibrations that travel for hundreds of miles. Engineers are now developing light-based data transmission systems and vibration-based sensors inspired by these forms of natural communication. Technologies that could revolutionize how we build underwater networks, deep space communications, or even medical devices that communicate with our bodies. The ocean speaks in silence, and if we listen closely, it teaches us how to communicate better than ever before. Every discovery beneath the waves echoes into our world above. Deep-sea biomimicry is already transforming industries, quietly but powerfully. Inspired by the sleek, smooth movement of sharks, Engineers developed sharkskin textured coatings that reduce drag on ships and airplanes, saving billions in fuel. The design has even been applied to swimsuits worn by Olympic athletes, giving them a measurable edge in performance. Then there's the coral reef, a master builder of strong yet lightweight structures. Its lattice-like design inspired architects to create earthquake-resistant buildings and self-healing concrete that mimics coral's ability to repair itself when damaged. In medicine, the ocean holds cures we're only beginning to uncover. Extremophiles, organisms that thrive in hydrothermal vents, have evolved enzymes that remain stable in boiling temperatures. These enzymes are now used in biotechnology, DNA testing, and pharmaceuticals, allowing processes that once required extreme lab conditions to happen more efficiently. Even biomedical implants are being designed after studying deep-sea creatures like sea stars and urchins, which can regenerate lost limbs or repair tissue. Their biology could lead to the next breakthroughs in regenerative medicine, helping humans heal faster and more completely. And the lessons don't stop at biology. Ocean-inspired engineering is reshaping renewable energy. The spiral structures of certain plankton and shellfish have influenced turbine designs that capture wind and tidal energy more efficiently, with minimal environmental impact. Some engineers are even experimenting with energy harvesting systems modeled after the way kelp sways with ocean currents, capturing constant, renewable power without disruption to marine life. From submarines that glide like manta rays to nanomaterials inspired by seashells, the ocean's imagination is boundless, and we're only at the surface of what's possible. But there's a deeper truth beneath all this wonder. As we learn from the ocean, we must also protect it. The same depths that inspire us are under threat from pollution, deep-sea mining, and climate change. Every coral bleached, every habitat destroyed is a lost blueprint, a chapter of nature's wisdom erased forever. Biomimicry teaches us not just how to create, but how to coexist. Nature's designs are circular, regenerative, and sustainable. Everything has a purpose. Nothing is wasted. Our challenge is to apply that same wisdom to how we live, build, and innovate. Researchers and conservationists are now working together to establish protected marine zones, ensuring that exploration continues responsibly. Ethical biomimicry means studying without exploiting, learning from nature without taking it apart. Because the ocean isn't just a resource, it's a library, the oldest and most profound on Earth. Every creature, every adaptation, is a page filled with solutions to problems we haven't even faced yet.